I'm having trouble like figuring out you know. Like, I feel like I found it like this. And please don't laugh at me. I know that you have to break.
Alrighty. Let's get going with what we need to do today. We're in 2-5. We're going to finish that out today. And we're going to start to see radicals and the solving stuff that are going to start to look a little crazier. They're going to look a little more wild. And it's okay. We're going to get through them. So we're going to get our one square root by itself. And then what do I need to do to get rid of the square root on this side? Square it, right? If I square this side, I need to square the other side. Not the other term, square the other side. The square and the square root cancel out. So this side's just going to be 7 minus x. What's this side going to be? Thank you for giving me 3 terms. X squared minus 10x plus 25. It is not x squared minus 25. Do not forget our factoring stuff just because things go a little wonky beforehand. Or multiplying polynomials. We're still trying to solve. We're still trying to get to an x equals. Which means, y'all, we need it to equal what? 0. So we're going to add x. And at the same time, I'm going to subtract the 7. That's going to make this equal 0. X squared minus 9x. Yep. 18. Does this factor? 18 and minus 9. What multiplies to be positive 18, adds to be minus 9. So we have 0 equals x minus 6, x minus 3. What are my solutions? X equals 6. X equals 3. Then we need to check it. Make sure we don't have any extraneous solutions. Nothing imaginary. So if we do x minus 6, are we going to get something workable in here? Yeah. So we'd have square root of 1. 6 minus 5, 1. So we have square root of 1 equals 1. Totally works. 3. 7 minus 3, 4. Square root of 4 is 2. 3 minus 5, negative 2. Is 2 the same thing as negative 2? No. So the 3 is extraneous. If ever we take something to a power in our solving process, you've got to check everything to see if we have something extraneous, because this one's extraneous, which means this is our solution. X equals 6. If ever we take things to a power, which since we're dealing with square roots, we're taking lots of things to powers, we got to check it. Go ahead, Jasmine. One. Usually 4 or 5 on these kinds of problems. Okay? So it's important. It's not like death if we don't, but it's important. Okay? They're going to start to look real gross because this next one looks real scary. There's lots of roots here. And I'm going to need to give myself some more space. So we're going to expand right and expand down. So we are going to pick a side and get rid of the radical, and then we'll get rid of the others. So since I already have one radical isolated, I want to get rid of that one. Which means I'm going to square both sides. Right? So when we do that, we're going to have on my right just 4 plus 3x. Because that's the whole point. Get rid of that radical. On the left-hand side, we're going to be careful. Because we have 7 minus 2x squared. So we just going to have the 7 minus 2x. These two times each other twice. Oh, I lost you there. I heard a lot of Scooby-Doo sounds there. Huh? Oh? So if you need to write this out, that's totally fine. I'll write it up over here. So our square root of 7 minus 2x minus square root of 5 plus x times square root of 7 minus 2x minus the square root 5 plus x. Okay, that feel a little clearer now? So we've got our 7 minus 2x times 7 minus 2x. So that one cancels out that square root. Then we're going to have 2 of the 7 minus 2x times 5 plus x, but still under the radical. Minus our 5 plus x. So it's going to look like that, and I'm running out of space, so I'm going to scooch my equals over. All right. It's the square. I wrote this out. This is this squared, because once I went to here, everyone went, huh? So this squared is this times this. That helps us see the 7 minus 2x times 7 minus 2x. Gives me the 7 minus 2x squared, which just cancels out my root. 7 minus 2x times the minus 5 plus x. 5 plus x times 7 minus 2x gives us minus 2 times that whole hot mess. Minus the 5 plus x, 5 plus x. Gets rid of the radical. Okay? Are we okay on this step? Where did I lose you? I was going to say I had a lot of no's, but not a lot of where. We squared both sides to get rid of the radical. So remember how on this, on this one, when we squared the x minus 5, we got the x squared minus 2 times 5 times x plus 25 squared. This is the same process, just grosser. First term squared minus the middle term, the two terms times each other. Square root of 7 minus 2x, square root of 5 plus x. When you multiply them together, they can go under the same house.
Why did we get 2?
Because when we multiply it, we get our outsides. 7 minus 2x times 5 plus x, right? And then the insides.
Oh, you trying to just simplify it though?
And we simplified it. Yes, 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 yes. When in doubt, write it out. Draw it out as your distribution. So square root of 7 minus 2x squared. That's this. Square root of, I'm going to run out of space real fast. 5 plus x times square root of 7 minus 2x. That's that one. Minus square root of 5x plus x times square root of 7 minus 2x. Last one. Plus square root, oh, sorry, that's a plus. X squared. Does that help a little bit? Yeah, it won't let me make more space up top. So green was here. Purple step was here. It won't let me make more space up at the top. It'll let me add on to the bottom and to the right, but not to the top or to the left. Because choices. It's just one of those, write it out, draw it out, or put it through a box. I don't care. Okay. Now that we have this, we need to simplify this left-hand side. I've got x's and numbers kind of all over the place. So I'm going to bring that minus 2 radical hot mess out front. 7 minus 2x, 5 plus x. And then we're going to simplify everybody else over here. What's up? I'm just taking this chunker and putting them up here. This piece? When we do our multiplying it out. No, because it's squared, not a difference of squares. Minus and minus. So minus one of these, minus one of those. They're the same, so there's 2 of them. It is not plus and minus. That has been squared, not a difference of squares. It's being squared. So it is x minus 5 squared. Same vibe. Go ahead.
So the negative is just like from the
because we have 2 of them. Yes. Yes. So now we're going to combine our like terms. I've got minus 2x, positive 1x. So we have minus 1x. I have a positive 5. I have a positive 7. Plus 12. There we go. My brain's good at braining. Okay. So then I still have a square root here, which means I need to get this square root by himself so I can square both sides and be rid of all the roots altogether. So I'm going to move these guys across the equal side. So we're going to minus 12 from both sides. And we are going to add 1x to both sides. So I'm going to have my minus 2 square root of the hot mess. Equals 4 minus 12 because it's negative 8 plus 4x. I would still like to get that square root by itself first. Divide both sides by negative 2. So we have the square root of the hot mess equals 4 minus 2x. Are we okay with the from here to here part? Yeah. No, we're still struggling with the multiplying top part, but the here to here, are we okay? Yeah. Okay. Because now what do we need to do to get rid of the square root? Square both sides. Square this side. Square this side. On the left-hand side, the square and the square root cancel out, and we're left with just our 7 minus 2x times 5 plus x equals, and then we're squaring this. It's the same process as up top, just less scary numbers. Square this. And if we need to, sorry, I got to zoom out so I can get a little more space. If we need to, write the dang thing out. Bless you. 4 minus 2x times 4 minus 2x. 4 times 4 gives me 16. 4 times minus 2x minus 8x. Let's see. Minus 2x times 4 minus 8x. And then, oops, wrong piece. Plus 4x squared, right? That is exactly what we did at the top. The top just has square roots and looks scary. 100% same process. To do this and this. Yes, dear?
Is that the only way that we can get the answer by doing?
Yes. Yes. We have to square both sides a couple of times on this because we have so many square roots. Okay, so this is 100% the same process as up here. 100% same process. This is just really scary because there's square roots in it, but it is exactly this. Okay? So then I need to simplify my left-hand side because my left-hand side is also full of parentheses and grossness. So we're going to multiply this side out, and we're going to have 35 plus 7x minus 10x minus 2x squared equals 16 minus 16x plus 4x squared. And now we have no more square roots. Yay! We do have squares though, which means I need to get this to equal what before I can solve it? 0. So let's add 2x squared to both sides. We can combine these guys together. This winds up being minus 3x. So we'll need to add 3x to both sides. And then subtract 35 minus 35. If you take everything to the other side, that's absolutely fine. I just go this way because it's going to give me a positive a value, and positive a values are significantly easier to work with. If you take everything to the other side, that's fine. Just then you're going to have to multiply everybody by -1 to get your a value positive. So we move the smaller of the x squareds and make everybody else play together nicely. So we're going to have 0 equals, I'm going to scramble things up too, 6x squared minus 13x minus 16 minus 35, 19. The 4x squared plus 2x squared. Got it? You see it? Okay. Okay. How are we on the from here to here part? Okay. Factor them. Factor the bottom. Six times -19 is -114, gross, minus 13. Kind of gross, right? 6 and 19. It's in our equation. They have a difference of 13. Okay? So when in doubt, check those values because sometimes we're not jerks. 6 and minus 19 straight up have a difference of -13. We'll multiply to make -114 and add to make -13. So we have our Factoring here, we're going to have 6x squared minus 19x plus 6x minus 19. I'm factoring with grouping. Factor however your little heart desires. As long as you can factor, I don't care how we factor. 0 equals. And our pieces that we can pull out, we're going to have x to get 6x minus 19. And what is shared? What's our common factor in this piece? 1. Don't tell me it's 0. 6x minus 19. So our factors are x plus 1 and 6x minus 19. Whew, almost done. So our solutions are x equals -1 and x equals, can you do this one in our heads? 19, positive 19 over 6. And then we got to check them. Whew. Which is a lot. It's a lot. I know, these are massive. I know. They're massive. I'm going to give us a little more space. So we're going to have the square root of 7 minus 2 times -1 minus the square root of 5 plus -1 square root of 4 plus 3 times -1. We write it that way, it's significantly less gross to do the simplification because we have here square root of 9 minus the square root of 4, and we want to know if that equals the square root of 1. It's 925. 3 minus 2 is 1. That one totally works. Positive 1. Because we have square root of 9, 3. Square root of 4, 2. Equals 1. Right? Then we can do the same thing with the fraction. It's less pretty, but it's doable. 7 minus 2 times our 19 over 6. Minus square root of 5 plus 19 over 6 equals square root of 4 plus 3 times 19 over 6. Really what we're looking for is, are any of these radicals going to wind up being negative?
Yeah.
Why? I'm not saying you're wrong, I'm just saying why. Tell me why. So 2 times 19 over 6, which is going to be 19 over 3, right? What is that as a mixed number? 19 over 3. So multiply it by 2 first, then simplify. 19 over 3. Simplify that. 6 and 1/3. Right? So is 7 minus 6 and 1/3 positive? 7 minus 6? Yeah, so it's going to leave us with 2/3. All right, 5 plus positive number, going to be positive. 3 times positive number, great. Plus 4, great. What? That was 19 over 6 times 2. Okay. Then, yeah, I simplified this piece so that we could make sure that 7 minus this guy is not going to give us a negative in our square root. Okay, so really that's what we're checking for, to make sure we're not having any imaginary numbers in here. So these are our solutions and they're both valid. Okay? These are kind of gross. Kind of gross. The next one's gonna look grosser, but I promise it's not as gross. It's gonna look grosser when we have to try and write it. That next one. Ew, I'm so silly. It's gonna look grosser, but I promise it's not as gross. So we've got the square root of 2 that still has a square root of x plus 1 underneath it. And on the other side is the square root of 3x minus 5. Okay. So I'm just going to grab this completely innocent piece of paper right here. What do I do if I just want to get rid of those outside square roots? Just square both sides. I'm just covering it for a second. Jeez. Jesus, you pantses. Oh my gosh. Okay, I want to get rid of those outside square roots. Both sides are isolated, so that we love. Because if I square this side and square this side, this square root cancels out and this square root cancels out. Right? Yeah, so we are left with 2 square root of x plus 1 equals 3x minus 5.
Yeah.
You can divide by 2, or if we don't want to deal with fractions, we can leave it this way and then square both sides to get rid of the square root. If we don't like fractions. Okay, because we generally don't like fractions as much. Like, we try and avoid them as much as possible, right? So instead of giving myself 3 halves and 5 halves, let's leave it here for a hot second. Okay? Because if I come in and square both sides, what are we going to have over here? 4 times x plus 1, right? Then we aren't going to have fractions that we're trying to square on the other side. So if you get fractiony grossness, back up a step and see if we can make it less gross, okay? That's going to equal, now we have to square this. And if you need to, write it out. 3x minus 5 times 3x minus 5. Do not make it a difference of squares. So we are going to have our 9x squared. Hi. Thank you. Oh, he's not here.
He's not here?
Nope. So we have our 9x squared minus 5 times 3x, so minus 15x, minus 15x, minus 30x, plus 25. Right? What's up? You good? I told you this one looked really scary, but it's not as gross. I told it looks really scary. Like, y'all panicked when we saw that double square root. But I promise it's not as hard.
You said it would look worse, so I thought it was
And I told it looks worse, but it's not as bad. Okay, so we need to simplify. I've got an x squared, which means I need to get this dang thing set equal to 0. So I'm going to simplify my left-hand side first. 4x plus 4. So we're going to need to subtract 4x from both sides. And subtract 4. I was going to say, You're not sneaky. I know you're trying to get them called out. I mean, just know that on the quizzes we don't get to use them. If you use them on the homework, I ain't watching over your shoulder. Just saying. But one of those things. Minus 34 plus 21. Sweet. Oh, 34x. Don't drop letters. Okay. So let's see if it'll factor. 9 times 21. 189. Has a difference. 34. Okay, so we're going to try and find a pair of numbers that multiply to be 189 and have a sum of negative 34. If my top number is positive, that means both of these are going to be the same sign. So we know it's a sum of 34, not a difference. Okay? So we're going to look for factors of 189, which if we need to make a table, that's totally fine. Things that multiply to make 189. I don't know why I did it that shape. There we go. So we have 1 and 189, always a fine thing. It's not divisible by 2. So 189 divided by 3 is going to give us 18 divided by 3 is 6. 9 divided by 3 is 3.
7 and 27.
You can do it that way. It's division by parts. So just like multiplying by parts. 18 divided by 3 is 6. 9 divided by 3 is 3. If you wrote it out, it's the same thing. You just do it in my head. Okay? I was going to say 4, it's not even. 5 is not ending in 5. It will divide by 6. Again. 32? No. Maybe it won't. 1. No, it won't. It won't divide by 6. But it will divide by 7, leaving us with 27. Which, if I sum those together, 7 and 27 is 34. Negative 7 and negative 27 gives us negative 34. Okay? So, if you are stuck, make a list of factors. So this gives us 0 equals 9x squared minus 7x minus 27x plus 21 plus. So what's in common between my 9x squared and my 7x? Just x on this part. 9x squared. Oh. What is shared between my minus 27x and my 21? Negative 3. That's going to give me 9x minus 7. So our factored form here is our 9x minus 7 and my x minus 3. So what are my roots? X equals 3 and x equals 7 over 9. Okay. So then we got to check it. Ooh, somebody's hand sanitizer smells good. So we're going to substitute them in. Square root of 2, square root of 7/9 plus 1. That's all adding, so that's going to be positive. That's fine. So we're going to have our 3 times 7/9 minus 5. Is that positive or is that negative under my radical there? Because we have 7/9 times 3, so that becomes 7/3, right? 7/3 as a mixed number. 2 1/3 minus 5 is negative. So it's negative under this square root. It's imaginary. We ain't dealing with that right now. So this 7/9, that one is extraneous. How about the 3? Does the 3 work? The 3 works. So that one's valid. Okay. Aside from the multiplying out the perfect square things that are square with the square roots in them, are we okay? Okay. Because I know we wanted to do one of the ones with the substitution thingy again, like the one we did at the very end of the day before with the U substitution. So I got one because it's going to come up again. So we had questions about it. So I want to try one. Okay? So there's some like this on the homework. So I want to make sure we have this. This is the U. So I don't like this x to the minus 2 here. Like, that's super gross. I would rather try and factor this when it was not super gross. So we're going to say, all right, I don't like my x's being x's. I'm going to use a U substitution, and I'm going to make my U be whatever the heck this middle term is. So x to the minus 2. It should always be whatever that variable in the middle is, whatever its powers and whatnot. So the one's going to be the same. This is going to be minus 13u. I'm in the middle. I'm working right to left so that we can think about our x to the minus 4th. How many u's is that? 2. U squared. Okay? This is significantly less gross to factor or solve in some way, shape, or form than having to deal with 1 over x squareds. We don't like having to do rationals. I would rather do it like this. Can this factor? No, which means what do? Quadratic formula. It's not going to be x equals. This time it's going to be u equals. U equals the opposite of b. So opposite of negative 13 plus or minus the square root of negative 13 squared minus 4 times 3 times 1 all over 2 times 3. And we're going to simplify this. U equals positive 13 plus or minus the square root. 13 squared? 169. Minus 12. 157. Over 6. Well, that's U. Now we know what U is. We get x to the minus 2 is this. Not negative square root. What does it mean when it's got that negative? 1 over x squared. Oh, that's a 6 in the denominator, not an x. We were just talking and I copied things down wrong. Square root of 157 over 6. What do we need to do to get that x squared out of the denominator? I'd really like it to do what? Well, you could conjugate it. That's hard way. I really want everything to just like flip, right?
Multiply it.
So you're multiplying both sides by the denominator, which we could then divide by the numerator, so we can just flip the whole dang thing upside down to make our lives a whole lot easier. If I flip this guy upside down, and I flip this guy upside down, don't they still equal each other?
No.
Think about it as x equals, or 1 over x equals 1/2. X equals 2. When I said it out loud, I saw a lot of brain blank. 1 over x equals 1 over 2. Can't I make that x over 1 equals 2 over 1? Does it change if it's x squared? Does it change if it's gross? No, it's just gross. So we're going to have x squared equals the 6 over. So square root both sides. It's nasty looking, but it's fine. 13. Square root both sides. And leave it gross. So our x is going to equal plus or minus square root 6 over 13. Leave it like that. It's gross, but it's there. I will also post the PDF here momentarily. I always post a PDF of the notes we take.